This video gives you some guidance for Lab 13. The lab is about the economics of minerals focused on rechargeable batteries and the minerals that are used for these batteries. You already had a homework that asked you about rechargeable batteries. Here we're going to look primarily at the mineral resources for nickel and lithium. The first page gives you some background, and you want to make sure to read this and realize this important point at the bottom of the first page, that there are 5 main types of rechargeable batteries. The activity begins on page 2, and it asks you to look at this graph that shows the number of cell phone batteries purchased in the US between 1996 and about 2004 or 5. Now, I have highlighted one of them in blue because it's really hard to see on this graph because it's so close to the zero value. The nickel-cadmium batteries are down here in blue. So that's where that line is. It's a little bit above the zero mark here, and it pretty much goes to zero right around the year 2000. The first question asks you to summarize the ways that cell phone battery purchases have changed from 1996 to 2005. So I think that's pretty straightforward, and you can just write a sentence for each type of battery. The next question asks you, why do you think the number of battery used have changed? And so this is sort of your opinion, but also if you want, you can do a little research into these various types of batteries and what they're used for. Question 3 asks you, what do you think that graph might look like for the entire world? There aren't necessarily right or wrong answers, they're just to kind of get you to think. Part 1b asks you about car batteries, and it says that one important characteristic of car batteries is their energy density. This tells you how much energy is contained in a given mass. And we want a battery that has a lot of energy for its size. This is called energy density, and it's listed in this table here. So high values in this column are more desirable than low values. Cost is another consideration, and that is in the last column. We want low values in this column, that's more desirable. Safety is another factor because we don't want batteries to explode, and so this table shows energy densities and costs for these 5 types of rechargeable batteries. It then goes on to tell you about standard car batteries and hybrid batteries. And so you're going to answer a number of questions here. Again, some of these are just to get you thinking. Now, there's a little bit of a format issue on this page. This bottom question really should have this explain your reason right directly after it. So you should put your answer over here. And if you want, you can put one sentence for each. In what ways do you think the demand for lead will change in the future, lithium will change in the future, and nickel will change in the future? The next question is a word problem, a math problem. Yay! It says that each car battery contains about 21 pounds of lead. Car ownership is expanding in developing countries. In 2011, there were 75 million motor vehicles or cars owned in China, and there were about 240 million owned in the United States at that time. China was expected at that time to own about 200 million vehicles by 2020. Assuming these vehicles will be standard gas-burning cars, each with an acid-lead battery, how much more lead in tons would be needed to meet that demand? And then I'm asking you to convert it into metric tons. So before we even get to the word problem, I thought it would be interesting, since it is currently 2020, to find out how good this estimate was. Well, it's an underestimate. In fact, the People's Republic of China has the largest fleet of motor vehicles, and it became the world's largest new car market in 2009. Currently, it has 360 million motor vehicles, including 270 million cars. But we'll go with what it says in the problem. So what do we need to do? Well, first of all, we simply need to figure out how many more cars China has between 2020 and 2011. So according to the question, China will have 125 million more cars in 2020 compared to 2011. And all I did was take the 200 million car estimate for 2020, and I subtracted the 75 million cars that were there in 2011. So 125 million more cars were estimated to occur by 2020. So what you need to do is, if each car needs a battery that has 21 pounds of lead, how much lead do you need for 121 million cars? Once you figure that out, you use this conversion factor here and figure out how much that is in metric tons. Next question asks to list several consequences that might arise from this increased demand. And one thing you can think about is, How might that affect the cost of lead? Part 2 is asking you to use the concept map on economic and societal factors that affect the flow of minerals. I introduced this in my learning video for Unit 5B. This concept map is not in this particular lab, but this page is downloadable and printable in the learning video for Unit 5B. So you can look there to find this if you haven't already watched that video and come across it. If you haven't watched that video, you actually probably should before you use it in this lab. So there's a number of things in question 9, and this is just the first page of it, that are going to ask you how these various things are going to look on this map. So based on the concept map, how and why should each of the following events affect nickel and or lithium demand or supply and price? And they give you an example. They say the only 2 lithium mines in North Carolina closed in 1986 and 1998. So let's go over here. What's that going to do? That's going to affect the mineral supply. And the mineral supply is going to be lower if we have these 2 mines closed. And when the supply is lower, it increases the price. And so their sample answer is this should reduce lithium production, which would lower the supply and thus increase the lithium price. So now you have to do these on your own. First commercial lithium-ion battery produced in 1991. So now you want to think about consumer demand. How is that going to change the consumer demand for lithium? And remember, consumer demand is over here. The next one says that the EPA classifies cadmium as group B1 probable human carcinogen. And that means it's unhealthy for humans. And it says cadmium is used with nickel in nickel-cadmium batteries. And this happens in 1992. So now you want to think about consumer opinion or preferences, which are down here. Is that going to be a positive or a negative? And then you want to think about how that's going to affect the price or the demand, or both. There are 3 more on the next page. Nickel plants open, commercial HEVs, global recession, and then this is just a list of some other things that happened. The last question is number 10, and it says to use the graphs on the following page, which I've just superposed here, and pick 2 of the predictions you made in number 9. So 2 from either these 3 or the 2 on the previous page, and explain how the data presented in these graphs on nickel and lithium production and price support or refute your predictions. So for example, I'll go back a page. Let's say that for this first one, you decided lithium became a higher demand material. And when it's higher in demand, it increases the price. So let's say that in 1991, you expect the price to increase for lithium. Well, here on the bottom, we have our lithium prices in year, and the value is shown here in the solid line, and then the production of lithium is in the dashed line. And 1991 is here, and here is the price of lithium, and it looks like it is indeed increasing, although something rather abrupt happens in 2001. But at least around 91, it looks like there is an increase in the price, and it also looks like there's a decrease in production until about 93, 94. And so maybe you want to include that in your explanation. So that's what you're going to do. And again, there aren't really right or wrong answers. There's just more or less trying to think about how what you predicted would match against the data. And remember, it says you could support or refute your predictions. You could say, well, my prediction was wrong. Because remember, there's a lot of other factors going on, such as what's described over here. Lots of other things control the price and production of various materials. Finally, I just want to remind you that there are opportunities to discuss these labs with your classmates, and I haven't seen people taking advantage of these. This is week 7's list of things that we're doing, and remember that we had 2 labs this week because they're kind of short. And this is lab 13, and I always have this discussion, this class discussion, which is optional. If you click on it, it brings you to this optional discussion, and you just hit reply, and you put in anything that you want, like, does anybody have an idea how to answer this question right here? Or I'm thinking along these lines, what does anybody else think? And you can have a discussion here with your classmates, and I think that that can be really useful. So just remember that that's there. Good luck, and come to my office hours on Monday if you have any questions about this lab.